Okay, hey, today, I'm going to do an example on the board right now of what your group should be doing here. If you haven't already, have your notes out. I would like this problem somewhere in your normal set of notes, not on that, the handout, the little arts craft project that we did yesterday. Now remember, the goal today was to fill in some of those properties that we may not have already filled in yet. So I'm going to do one problem first, and I'm going to have some of your groups go, and then we're going to get to the homework today, which I'll put on the board here in a little bit. But I'll let you have a little bit of time. I'm going to do one problem, this one. I would like you to draw this entire problem out in the notes, put your numbers, I'll give you a little bit of time to write this down. Yep, so put it in your regular notes, please. So I'll give you a little bit of time to write this down. There's a lot of stuff going on in this problem. I'll explain it as we go. There's a reason why I'm picking this one. Now, if any of you in this room have this problem in your packets, it probably is not supposed to be there. I accidentally threw it in there.
Did we look at this yesterday?
Not this one. Not this one. We had ones that were very close to it, but not this one in particular. Alright, did I give everyone enough time for this? Now, here's my question to you. If you're opening up the little art project that we did yesterday, there was two in particular that we have not covered yet, correct? There was two.
I don't know. Yeah.
Was it the, it was just the bottom one?
Well, did we have a picture for 3.4?
No, we didn't do the rectangle yet. How many do we have to fill in?
Three.
Three? Two. 6.6 or 6.8?
Yeah, 6.6 and 6.8.
6.6 and 6.8. Okay, yeah, that's what I figured. Those I'm not too worried about. It's those other select views, 6.7, 6.4, 6.3, 6.5. Those are the ones that you should have pictures next to you. The reason why, the only time you'd ever use 6.6 if you have a right angle. Now, this problem does not have a right angle. We'll see it here in a second why it doesn't. You can actually see it yourself. It doesn't have a right angle in it. So we're not going to be using 6.6 on this one. But the problem is this one is so unique we had to discuss it. It was one of the problems I found in the book. It was one that I'm not assigning. But it was when people first start this problem, it's overly difficult because they don't see how to attempt this problem. Okay, what I mean by that. On this problem, there's certain things you can do right away. Like for instance, if this is truly a parallelogram, which it says up in the instructions, these are all parallelograms. What is the number for B? 8. Okay, that property, moving this 8 across, is something you should have had earlier on 6.3. So if you look back at the picture you had for 6.3, the theorem on that little arts crafts project, you had to transfer the walls across the picture. So now, I don't have it on this one. If there was a letter down here, you could transfer the 15 down to the bottom. That was 6.3. You already had a picture of it yesterday. I think one of our groups actually presented it. It was the first group here that actually had that. So we should have had that problem or that picture in there somewhere, okay, where you can transfer the numbers across. Does everyone understand how to find B? Okay, you're going to have to do that quite a few times on your pictures today, but the opposite walls can just be transferred over. That's how you can find the variables really quick. Okay? Now, the next part, what makes this problem so difficult is that triangle over there, this triangle right here. A lot of people would miss it. You would actually not see what it's actually giving you. That triangle that I have a little dot in is isosceles. A lot of people would never see that. The reason why it's isosceles, two walls are actually equal to each other. It's got an 8 and an 8. This 8 right here is this diagonal. That 8 is this line going up and down. That's an isosceles triangle. If it's isosceles, where the two legs are the same, that means these angles are the same. Because those are the angles that are pointing at it. This is the base, right? So that means this x can be transferred over here. So if we knew what x was, I can now transfer it to that corner. Yeah, say it again?
X is 56.
X is 56. So that's why it's useful. By seeing that that's an isosceles triangle, we can actually find x, which is that corner there, because, you're absolutely right, this 56 can hopscotch to here. It's called an alternate interior, right? It goes to the opposite corner, right? That's almost a piece of 6.4. The angles can transfer to the opposite corner. So this x here is a 56, and so that makes this one 56.
Why?
Because it's isosceles.
Oh, wait. Oh.
Two walls are the same, so two angles have to be the same. Yep. Without knowing that those 8s are there, we would never be able to do that. But knowing the 8 sitting there, boom, now I can actually transfer the 56 there. And now I can find the y. Now, to find this one, this is going to be a random third letter. You know, this is my mystery angle. What do triangles have to add up to be?
180.
180. So you can go 56 plus 56 plus the y that's sitting in that corner, and that should make 180 degrees. These are things you'd have to do off to the side. This is 104, or geez, 112, what am I doing? So 112 plus y equals 180. You would actually subtract this across, and you get what, 68?
Yeah.
Okay, and that would be the y. So we have x's, x is a 56, we have y, we have b. What's a? 8. B is also 8, or sorry, a is also 8. Now here's the reason why a is 8. This stick right here is the same as the other one, because the diagonals bisect each other. That should have been something you had on 6.7, that the diagonals bisect each other. So the diagonals are the same. So this 8 is also A. And then this 9 could hop down to here if you needed that one. I don't need it in this particular case. One of our groups that will present today will have diagonals that are congruent. Which I think the first group had that. They had one of those we could transfer, I think. One of the first groups in. Okay, questions at all? But we only had one group that presented yesterday, correct?
Two.
We had 2 groups?
No, we
It was
We had one.
one group presented?
One.
Okay.
Alright.
All right. Well, that was kind of the idea. I want to talk about this problem. This problem in particular was difficult because of that isosceles triangle. A lot of people would never see that. So I want to make sure that we knew how to find those numbers. Okay, questions, comments, concerns? Perfect. All right. Goal today, I'm going to have some other groups present. We had the first group that went yesterday, that was this group. Second group, I don't know if I already numbered you guys off yet.
No.
Okay, we'll just have second group. You guys want to present? Bring up your problem, the one that you had. If you need maybe 2 minutes to collect yourself, get kind of back in that frame of mind, let's do that. Let's take 2 minutes. Take 2 minutes, review your problem one more time. I'm going to walk around the room to make sure you guys know what you're going to discuss and that your properties are right, and then we'll get started here today. Okay? All right, here we go. Okay, second group, come on up. I'll put it on the board. You guys don't need to draw it or anything like that. I'll have it up on the board. Okay. Go ahead. All right, everyone in here, let's pay attention. Go ahead.
Okay, so use 6.3, the opposite angles, or opposite sides. So this equals this equals this. So to find the variables, you set them equal to each other. So 3y equals 15. Divide them both by 3, and you get 5. Okay, that's the one side.
And what was the theorem again that you guys used?
6.3.
6.3.
Opposite sides.
Good. Keep going. Very nice. Very
And
nicely
then
done.
to do the other one, you set the other ones equal. So 2x plus 8 equals 14. subtract 8. 2x equals 6. X equals.
Perfect. All right, give him a round of applause. Good work. All right, very nice, very easy. Again, using 6-3, the opposite sides are equal. You set them equal and solve. That is a perfect example of what your homework will look like today. Very easy, very short, quick types of problems, but you got to know what to do. Thank you very much, Group 2. Group 3, that's you guys. Taylor, just go up there and point. That's all you need to do. All right.
I'll stay up there.
Which number you guys have? What were the numbers in the corners?
That's what I get for being late.
56. Okay.
Hey, at least you didn't have to go over all those. And appreciate it, yes. Because these two, no,
All right, here we go.
nothing.
Fire away.
Okay, so these two angles are equal because they're opposite angles.
Which is 6.4.
And then, we knew that these were consecutive, so it has to equal 180.
Yeah, so that the y would be 38.
You want to explain why it's 38? Kind of show the math off to the side why it's 38. I'll agree with you, but I want to see why it would be 38.
And
Oh,
that's-
there you go.
Yeah, she was doing what you said.
Ah, perfect.
And then that would be 6.5 too. So that's 6.5 postulate.
Okay, and stop after you get done with this one before we solve
So
for
it's,
z.
38.
Okay. I love the way that they set that up. If you didn't hear them, they used what? What was the theorem?
6.4. So then it was 6.5.
6.5. Yep. That. If you notice the angles they added the entire angle A, which is 56 plus you, and they added entire angle B, which I love the way that you wrote that down. Because you're showing everything you're adding to make 180. They're consecutive angles, so side by side, they have to add to be 180. And then you solve. Perfect, keep going.
And then z is equal to 85 because those are opposite angles as well.
Which is 6.4 again.
Perfect. Yep, 6.4, you can transfer that 85 in. Or there's another way to do it. Does anyone know how to also find z if you didn't know the opposite angle object?
Animal,
Yeah, what did triangles have to add up to be?
180.
180. You had the triangle. You had the y. You had the 56. You could find z then. Because triangles have to add up to be under 80. But the easiest way to do it is exactly what you said. You just transfer the opposite angles to the opposite corners. Perfect. Give them a round of applause. Nicely done. Again, the majority of that one was 6.4 and 6.5. You just bounce angles around the picture a little bit. But I love the way that they set that up to find y. That you added the two corners to make 180. Okay? Group 4. Yeah. All right. What was the problem that you guys had? And okay.
I like the t-shirt. Rick Dalton.
Hanson, you gonna go up there and just point and
No, he'll be okay.
is this it?
I guess, so.
Not gonna stand up there and support? Oh, okay.
Guess not.
All right.
No.
No. All right. Fire away. What do you got?
Okay, so alternate interior off the bat. So you got set 6y plus 5 equals 35. You gotta solve for that. So 6y equals 30.
Thanks, yeah, got a second.
And then you divide by 6 two sides, so y equals 5. And then this angle obviously equals 80, but a full triangle has to equal 100, so 5x has to be 100.
The whole corner.
Or the whole,
The whole corner.
has to be 100.
Yep.
So would you set 5x to equal to 100? Or,
5x plus what is the angle right next to it?
oh, 5x plus 6y plus 5.
Equals 100. And you know the y already.
Yeah.
Yeah.
Okay.
So write that down.
Oh.
Okay, now I'll kind of fill in gaps, but he's absolutely right. He did solve it correctly there. All right. So if just point out what you have written down there. That part right there. Why is that angle in that corner 100? You didn't say it earlier. You said something about triangles.
Because the whole triangle has to equal 180 right here,
Okay.
and that angle is already 80, so it has to be 100.
Close. Close. No. Close. You're close. Here's the reason why. Point at the upper corner where the 80's at. The 80 is the whole corner. The whole corner. Not just the part of that triangle. It's the entire corner. The bottom had to be 100 because of what group 3 did earlier. that the two corners have to add up to be 180. The top corner and that bottom corner. So that meant the bottom corner had to be 100 because 100 plus 80 is 180. And what, so Dalton, back up so you can show what you wrote down. That was absolutely right. The thing you wrote down there, 50 or 5x plus the 6y plus 5 has to equal the 100 that's sitting there. And we already know y. What's your y?
5.
You can plug that in and now you can solve for x.
25.
Okay, yeah. So, nicely done. Give him a round of applause. All right, very nicely done. But it was based on the last group because I want to get more practice with that. That formula that you're actually looking at there with the two groups, that's the most challenging type of problem that you're going to have, where you have to understand that the corners have to add up to be 180, even when there's multiple letters sitting there. That you have to solve for one of them so you can use it later. Okay, very nicely done. Group, what are we on? 5. What problem do you guys have? Hold it up so I can see it. Got it. All right. Reese. All right, this is a good one. This is a lot like the problem I did earlier today. Okay. Fire away. What do you guys got?
Alright, so right away, A equals 10,
Oh, here a second.
because 6 plus 4. And then there's a 90 over there, so if there's one 90, they're all 90, so x equals 90. And then that leaves y with a 45. And then since these angles are the same, this 4 can transfer over here, so that's 4. So B equals 4 over here.
Doing it insanely fast, and he's absolutely right. All right, go back to that first angle you threw over there, the x,
Alright,
the 90. What property is that?
6.6.
6.6. There's your picture right there, 6.6. That's the picture you need to have in your notes. Apology. Mr. Ward. Yes, I do. Okay, yes, I will. Yep, fine. Nurse station. Okay, all right. So 6.6, that example of throwing the 90s in the corner. So in fact, I would like you to actually put 90s in every corner if you can. Boom. That's 6.6. This is the picture I wanted you to have for 6.6. That they gave you one right angle, so you could throw right angles in all the corners. Okay, then we'll get to the other stuff that he eventually led up to. Both of them led up to, I should say. But nicely done. Okay, now, before you walk, how did you know the 45 was y? Let's start there.
Because it has to add up to be 190 or 180. So 90 plus 45 plus y equals 180.
Yeah, it's a triangle that he's sitting in. He's absolutely right. And so he found 45, and then you went with the 4s, you transferred the 4s around, because what type of triangle is that, really?
Isosceles.
Isosceles. And then you can transfer the 4 across. Lots of properties there. So you said, what, 6.6 was the main one? How can I transfer the 10 and that 4 across? What was that property? Opposite sides? Which one is that?
6.1 or 6.3.
6.3. Yeah, opposite sides. That's why the 10 can transfer over. In fact, I really like the fact that you wrote A is equal to 10 right away, starting with that, because you added the 2 bottoms. That's really clever. A lot of people wouldn't attempt to do that. They would just go, well, I don't have A. You have the entire bottom. Those transfer. So very nicely done. Give them a round of applause. Both of them. Very nicely done. All right, last group, please. Very good. All right, what was your problem that you guys had? Can you hold it up so I can see it? Perfect, got it. Okay, last one today. Fire away, what do we got?
Okay, so these have to equal each other. So I'm going to do 3x plus 4 equals 25. And solve for it. And then we divide 3 over. And that equals 7. And then we have to take the 2y minus 8 equals 28. And then solve for that.
what property allowed you to set those equal? You are correct.
6.7.
6.7. There's a good example of 6.7 if you don't have a picture already for 6.7. The diagonal set equals to each other. Give them a round of applause. Okay, there's all the groups. Now, the only one we don't have was, what, 6.8? Okay, let me show you one of the problems that maybe the groups did not choose. Here we go. Okay, right here. This problem in particular, why this is important, is that the two triangles are exactly equal to each other. This is actually the picture I'd like you to put for 6.8. Do you agree that there is one diagonal on the picture?
Yeah.
Okay. The triangles are exactly equal to each other. That's what 6.8 says. So if you have a triangle up here on this parallelogram, that is the same as this triangle. That's why all the numbers can transfer. So that's why the 80 can transfer down to the x, because this triangle, if you were to like turn and rotate the picture, like if we were to just like turn it around, it would land right on top of this one. So this would be your 80. This would be the 30 down here, because that angle would like pivot to here. This angle, which is in this corner right here, which is 70, would have to transfer up to here. And why I know that's 70? Because triangles have to add up to be 180. So that's 70. Then you can transfer, like if I rotated the picture, the 15 comes down here, the 8 would transfer over to here. So that was your 6.8 picture. That when they draw one diagonal, everything can rotate and it's the exact same triangle on top of each other. Bless you. That's why really all the numbers can move around the picture. Because when you rotate, you'll actually get the same picture.
Procedure for the
But again, it's using every property. Opposite angles, it's using the opposite walls. But just knowing that the triangles had to be equal, that's why the numbers can transfer to the other picture. Questions, comments? Okay. I'll leave that up there just for a little bit so you guys can see that one. But this is a good example of 6.8. Does anyone, other than Taylor, because we'll get you filled in, does anyone have any other blanks on their pictures? I think we had everyone had an example next to it now. But again, the whole point of this one was knowing that the triangles had to be equal. Okay. That was what 6.8 said.
I have that part.
Okay, sorry. Okay, we're good? Anyone else need it? Okay, here's your homework today. I said you're going to get homework, here it is.
My notebook is on the school.
Here's your homework today. It'll be due on Tuesday next week. I believe that is the 13th, if I am not mistaken. So, it's page 407. I just picked a select few problems. Some of them, they just give you a picture. They want you to find the certain variables. I believe the last one, 31 through 36, it's one single picture. And and each problem, like 31, 32, is just find a different letter on that picture. So it's one picture. But the rest of them are like their own, and they want you to find X and Y. That's really what they are. But you have to know that you can transfer walls, you can transfer angles. Certain angles have to be 180. If you were following along with any of the problems we've done today, you're going to be more than fine. Like the problems I picked today, some of them were insanely difficult. There are some tough problems out there. Wow, you guys had it. I wonder where that picture went. You guys have 4? 3. 3. You guys have 3. All right, there you go.